Okay, this is the Math 1113 Zoom meeting for 10 a.m. March the 16th. This week we're doing section 6-4, practice problems 9 to 33 odd. Again, not for a grade, but the quiz on Friday to Sunday will be based on them. WebAssign, your personal study plan, and your practice quiz, section 6-4. Work problems 1, 2, 3, 4, and 5 only. And again, just email me the percent of these 5 problems that you get correct. So section 6-4 is about graphing the other 4 types of trig functions. Call it more trig graphs. More trig graphs, and you can see tangent, cotangent, secant, and cosecant. So you're going to graph cosecant, and you're going to enter it as 1 divided by sine. Cosecant x, 1 divided by sine x. Secant x, you'll enter it as 1 divided by cosine x. Cotangent x, you'll enter it as 1 divided by tangent x. You could enter it as cosine over sine too, if you wanted. Tangent x, you'll enter it directly. You got a tangent key on the tangent key. So you do have a tangent key, but you don't have the other 3 keys. Okay, there will be much less. All these functions have one thing in common on their graphs: asymptotes. Remember, a line, a graph approaches but does not cross. Okay, let me argue out cosecant first. Okay. It works off their paired inverse. Off their paired inverse. In other words, you need to graph sine of x first. That's why they were done in the order they've been presented. Okay, so if I'm going to graph y equals cosecant of x, I graph y equals sine of x first. All right, hopefully you remember this from last section. Sine of x starts in the middle, goes up and down like a wave. Okay, goes up to 1, goes down to -1. I probably should have dashed it. If I'd thought, I'd have dashed it. Okay, now I'm going to take inverses at specific points to graph cosecant is 1 divided by sine. All right, this is directly sine x. Okay, you can start, the easiest point is these peaks or dips. You're down at -1. You're at -1. The points at the peaks and dips do not change. They're on the cosecant graph. Points at the peaks and, or you call them the humps, and valleys, dips, do not change on the cosecant because you're at 1. 1 over 1 equals 1. You're at -1. 1, this is at a hump. 1 over 1 equals 1. 1 over 1 equals 1. 1 over 1 equals 1. So those points are simultaneously on both graphs, as are these. 1 divided by -1 is -1. -1 equals -1. These points, they're on both graphs because when you inverse them, they're at 1, they're at -1, they don't change. Inverse of 1 is 1, inverse of -1 is -1. Okay, the next point are these x then do x-intercepts. Because at the x-intercepts, sine equals 0. Cosecant will then equal 1 over 0, which is undefined. This puts asymptotes at each x-intercept. So at every x-intercept, there's already the y-axis here. I can't really overwrite on it, but notice how it goes, vertical line right through that x-intercept. There'd be a parallel one here. There, parallel one here. Didn't really have to dot it. Parallel one here that implies there's a point there. I wish I hadn't done that. All right, and there's one here. There's not simultaneous points. Every x-intercept. All right, so then what you get, I'll argue it out on this and then you can see what happens on the others. At some point you will go through 1/2. Well, 1 divided by 1/2 is 1 times 2 over 1, which is 2. So in effect, this flips up to 2. This point goes up to 2. 1/2 here flips up to 2. Same thing here. You're at 1/2 here. You'll flip up to 2. So this forms a U. Coming down, intersecting here at the peak, going through that, and you're approaching these vertical lines. In effect, the hump flips. All the humps flip. Same thing happens over here. This point and a half flips up to 2. A point and a third flips up to 3, etc. On both sides, forming U's. This one, same thing. I didn't draw that in there. Hump flips. All right, well, what about these dips? Same thing, you're at -1/2. It'll flip down to -2. A point at -1/3 will flip down to -3. So I'm into my words, but the dips flip and form downward facing U's. That asymptote there. This one flips down, and so on. And so the cosecant graphs are these U's, are the U's. You can see down here, the cosecant graph is the u's. All right, well, let me show this on the calculator. First thing you want to do is graph clear. Oh, make sure you're in radian mode. I'm in radian mode. Okay. Y equals sine x. Okay. And then you want to enter 1 divide by sine of x. You'll see this process play out in real time here. You graph the sine first, you'll see the wave go through. When you graph cosecant, you'll see every hump flip. You won't see the vertical lines, but it's staying inside those vertical lines when you do it. You know, you can almost use like negative 10, 10, 1, and it'll show you enough humps and dips. Maybe I'll go negative 5, 5, 1. And you now, the thing is, vertically with sine and cosine, you stayed between 0 and 1. But you're going to want to see, you know, up to here and down below. Maybe we'll keep it negative 5, 5, 1 vertically there on Y min and Y max. Again, there's no single correct way to do it. All right, let's see what we get. So you're going to see your wave going through. There's your wave. And now you see the bottom hump flips down, the up hump flips up, flips down. And I want to see, maybe I'll just make it minus 10, 10. We can see a few more. Minus 10, 10. So there's the wave going through. Drawing the wave. And there you are. Every up hump flips up and every down hump flips down. Exact same thing will happen with cosine. It just shifted back. The U here will be centered around the y-axis. It's not showing you the vertical line. Only one you can see is the y-axis. You can see how the U's approach the y-axis there. You don't see them here. It doesn't draw them. Can't draw vertical lines on the calculator. It violates vertical line test. Calculator does functions only. Okay, well, that pretty much handles sines and cosines. Cosine is identical, just shifted back, and secant shifted back. So if I want to graph secant of x, graph equals cosine, and flip the humps and dips up or down. I'm trying to use very technical language here. So I'll dash the cosine. Remember, cosine started in the middle. Okay. The points at the humps and dips are identical. You're flipping negative 1 and 1. Every x-intercept will have a vertical axis because you're flipping 0. 1 over 0 is undefined. Your 1 over 1 equals 1. 1 over negative 1 equals negative 1. There's a x-intercept through there, x-intercept through here, x-intercept through here, 1 here. And then these will flip. And so this is the secant graph. This one flips down. Oops, sorry. This is the secant graph. All these U's staying between these intercepts are on the secant graph. You can see the only differences with sine, it was totally to the right of the y-axis. Secant, it'll be centered at the y-axis. That's because sine was an odd function and cosine is an even function. So I would graph cosine x and 1 divided by cosine x. And you can use the same windows. So there's, yeah, see, cosine centered at the y-axis. Remember, it's even. Get the same number out, and then there's the humps are flipping it up, you can see the humps flip up and down. Okay, in terms of what parameters we're going to pick off of these two, the model is pretty much, let's see, I'll pick it off of page 538. And they do y equals a cosecant of kx, and y equals a secant kx. Okay, here's the big difference on a cosecant or secant. That is CSC. Sorry about that. Can't erase. That's the one big difference with the blackboard, is that I can't erase, unless I use pencil, I suppose. Suppose I could use pencil. A is not amplitude. Amplitude implies a hard limit, and that applies to sine and cosine. The amplitude on sine, cosine, stratum was equal to 1. It's the front coefficient, or the A value, if it was different from 1, if they give you an A value. No amplitude. It's just a front coefficient. It basically controls how wide or narrow the graph is. That's it. On secant, cosecant. That if there was, there'd be some hard number up here that it didn't go past, but it does. These go up forever. Okay. So A just controls how wide or narrow the U's are. It really has no name. Narrow the U's are, there's really no name for it. The period, put that up, identical period for secant, cosecant, identical to sine, cosine, period is 2 pi over the k. It repeats exactly the same distances that sine and cosine do. No change, all on the period. We will not worry. We will not do horizontal shift or vertical shift. Don't thank me all at once. On secant, really on all four, or cosecant. We'll just pick one out of the book. Why don't we try this is page 6.4, page 540. I guess we'll try 17. Y equals 3 secant of x. Graph. And they just want you to find the period. Find period. All right, well, that's pretty easy. It's 2 pi over k, which is 2 pi over 1. The k value is 1, just 2 pi. So period straight 2 pi. 3 is not amplitude. So number 1, we're going to graph y equals 3 cosine x. And then number 2, we're going to graph 3 divided by cosine x. this is equal to your 3 secant. The cosine is 1 over secant. Cosine equals, so let's like taking 3, 1 over secant. This is equal to your cosine. 3 cosines taking 3, 1 over secant, and then you can multiply the 3 and the 1, getting 3 over cosine in effect. You graph 3 secant. Maybe that's what I should have done. To graph 3 secant, that's equal to 3 times 1 over cosine. Remember, secant is 1 over cosine, so 3 times 1, that's equal to 3 over cosine. So I'm graphing the cosine first with the front coefficient. This is amplitude on the cosine, but they didn't ask for that. The 3 is not amplitude on the secant. So we're going to graph both of these. The only thing I might want to change, horizontally, I'm fine. Vertically, I might want to go, well, I don't know. I went -5 to 5, I'm showing 3. So I'm going to go up to 3 and down 3. The cosine is going to be amplified a little bit. Let's just see what we get. Then you can play around. Oh, I didn't enter it. My fault. All right, so we're going to go 3 cosine x and 3 divide by cosine x. That's actually my secant. All right, so you got a bigger wave here. It's going up to 3 and down to 3 in the center, and then your humps just flip. X-intercepts through every, asymptotes through every x-intercept. You see the y-axis on a cosine is not an asymptote. It's splitting the u. The u is not approaching it. There's a vertical asymptote here, you can see, and the u is split. So if I wanted to sketch that, going up to 3, going down to -3, I drew a sine. My fault, I drew a sine. And 3 divided by cosine x. Cosine high in the middle. So you're up to 3, you're down to -3. Vertical asymptotes that the calculator does not show you through every x-intercept. Humps and dips coincide right there, and they flip just like this. And so on. Okay, why don't we try tangents and cotangents? And that's the last two here at 6-4. Y equals tangents. Y equals cotangent. And my Wi-Fi froze. Let's see if it'll unfreeze. No. Let's pause the recording. Okay, we're back. Yeah, Wi-Fi went out for whatever reason. So on these, you are going to get a series of S-curves. Are going to get series of S curves. Treat each one individually. Do not graph, in other words, do not graph tangent to get, flip something and get cotangent. Okay. you will just get a big mess. You will just get a huge mess. Okay. Treat each one individually. I don't know if you have the patience for me to argue it out, or if you just believe the calculator. I'll just start with tangent. Graph tangent of x. So I'm going to go tangent x, and clear that. Window, I'm going to switch to negative 10, 10 on the y, negative 10, 10 on the y. Graph. Oops, what did I blow? Equals, oh, too many parentheses. Okay. Graph. All right, you get these series, we call them kind of S curves. Notice the main center one is the one we usually draw. It goes through the origin. It is not showing you the asymptote where the next one starts. There's an asymptote. And then there'll be another asymptote over here. It's not showing you, and it doesn't cross or touch. It shows you that one, and then there's another one back here, another asymptote that binds the next version. So you just get these series of identical, these go forever kind of S curves. And if there's nothing you can flip here that'll help you draw the cotangent. It doesn't work like secant and cosecant and those other four. Just treat them individually. You'd have S curves crossing everywhere if you tried it. It's a huge mess. Okay, just to try to argue it out, remember tangent is y over the x. So I'll just argue out the first quadrant. If you start at 1 and 0, your tangent is 0 over 1, which is 0. And that gives you the origin point. X is your angle. All right, well, another obvious point, turns out, is 45 degrees or pi over 4, and it turns out that's where you'll be 1. Because remember, you're up here at root 2 over 2, root 2 over 2, and your tangent will equal 1. Okay, so you're increasing up to 1. Then when you get to up to here, you're at 0, 1, and your tangent 1 over 0, which is undefined. Notice that angle is at pi over 2, and that's what the asymptote value is. So that explains, it approaches asymptotically, it approaches pi over 2. When you back down, this is in other words first quadrant. Well, the other side, when you go negative angle, you're going down this way. And your pi over 4 will go down to negative 1. At negative pi over 4, and down here at negative pi over 2, your coordinates are 0, negative 1, and your tangent is also undefined. Your tangent equals negative 1 over 0, which is undefined, and you're approaching this. Okay, and then these just repeat as you go around. Now, the important thing, here's the important difference. This is one period. You can do it from pi over 2, the difference of pi over 2, this is at negative pi over 2, I'll put it up here, negative pi over 2, minus negative pi over 2, well, pi over 2 minus negative pi over 2 is pi over 2, half pi, pi over 2, add pi over 2, which is pi. So that's the huge difference, period. On tangent, cotangent equals pi. On their model, y equals a tangent kx or a cotangent kx. Again, a is not amplitude. It just controls how wide or narrow the S curves are, but period is pi over k. not, this is on tangent, cotangent, 2 pi over k. That is sine, cosecant, cosine, secant. Here it is 2 pi over k on all these 4, but pi over k. Tangent and cotangent repeat themselves every halfway around the circle, not the full way around the circle. That's the main differences you've got to realize. Otherwise, it's just a matter of graphing them on the calculator and being able to copy their graph. I can show you the model out of the book. Let's see. Right here. Now, these are not showing any horizontal shift or any vertical shift. The book does have problems with those in it. I think I stopped the homework at 35 before we got to those. So we're not going to mess with any horizontal shift or vertical shift. These don't thank me all at once. Why don't we try an example here, page 540. Why don't we try, just number 9, the first one. Y equals 3 tan x. Once again, you don't draw a cotangent or anything. You don't pair anything with it. Just enter it by itself. Copy down what you see. 3 tan x. Pretty much use a standard window graph. If you can compare it to straight tangent x, but the curves are a lot steeper. They go up 3 times quicker, in other words. They do want you to find period, and it will be period will be pi over the k, which is just pi, and you will have the same asymptote values on this. The 3 again just makes it go up and down quicker. Just draw a series of S curves up and down quicker. And this is still at pi over 2, and this is still at negative pi over 2. And your period is pi. You don't really have to, label the asymptotes. The idea is just give me, 2 or 3 S curves. We'll make our last problem a cotangent. Why don't we try one like 13, page 540. Y equals negative cotangent of x. Okay, now we're going to enter this as y equals negative 1 divided by tangent x. Again, don't pair it with anything. It will just give you just a huge mess. Negative 1 divided by tangent x. That is a negative cotangent x. We'll just keep the same window graph. Getting kind of the same kind of S curve. Looks like the y-axis is an asymptote on this. So actually flipping upside down making a cotangent negative is pretty much identical to having the same thing as a tangent. Actually, I'm drawing this wrong. It doesn't go through the origin. Sorry about that. It goes over here and approaches the y-axis. Approaching the y-axis, and then it just approaches the negative y-axis, doing this. You can draw in the asymptotes, and then it does another one. Here's the y-axis, the x-axis, and then one is this direction. There's no real set number on how many to draw. Okay, period. Again, is pi over the k, which is pi. Pi over 1, which is pi. All right, I hope this helps. Shouldn't be too much. Just a few technical differences on these 4 graphs from the others. So hopefully not a hard section. I just want you to practice graphing these other 4 functions. So I hope you all, have a good week, and email me with any questions. And we will have another session. I think we set it for 4 p.m. Thursday because I can't meet it all on Friday. We'll see you then. Thank you.